Come join the community and let's discuss some big ideas. What is this text? You can't read this. What are we just supposed to say like, oh, okay, yeah, there's words there. It must be telling us something good. So this is the text, and because you couldn't see it in the other video, you can see it in this video. Let's have a look at this. This angle is of such a huge distance.
They might begin to question what they were being taught about the cosmos, the universe, the Big Bang, evolution, and much else.
Yes. Once again, like I predicted, I don't like the fact that evolution is an observable fact, so I'm gonna, I don't like that the universe is big. This is so stupid. Brian Grossman from my Belief Talk episode, the person who was the anti-Semitic flat earther, has sent me this video to critique. He said, check out this video. It's called Airy's Failure, Proof of Stationary Earth. Now, I am not a scientist. I don't know much about flat earth theories, or I don't even think they have a theory actually. I think they have a few hypotheses, but they don't actually have a working theory. That is something that we can use to make novel testable predictions with. However, I do work in the spatial services industry, and I do know that in our data recorders, we have to put in certain mathematical formulas to compute 2D plans onto a spherical Earth, because even over, say, 200 meters or so, there will be a slight deviation in degrees, minutes, seconds with where the points will actually end up, depending on where you are in the world, because we're not on a perfect sphere, we're actually on a geoid shaped Earth. So let's check out this video and see if we can't pull apart some of the misinformation, which I'm sure it is ripe with. Brian, I'm not going to be as friendly as I was in our chat, and that's only because this is a different format. In Belief Talk, I try and be as calm and collected as possible and try and understand your perspective, but in this, I'm critiquing it, so I hope you don't take offense to anything I'm about to say. And my wife just asked me to help with shopping, so I'll be right back. Okay, back from helping my wife. So let's jump to the video. You always know there's going to be some good scientific merit when it starts with a really slow, ominous tone to make you really get in the mood, because science is all about mood.
If a
Okay, it's taking 31 seconds to get to content.
telescope is pointing at a star, and both are stationary, then obviously the light comes straight into the telescope. In 1729, Bradley...
I think that's a very... These scales are very, very simplified.
found that he had to tip his telescope forward very slightly to get a star in the center of his telescope. It was assumed that this was due to the motion of the Earth around the Sun. Let us assume that the telescope was moving at 5 miles an hour and had to be tipped 5 degrees.
Okay, so let's work that out. So was the telescope moving at 5 miles per hour? This is also assuming that the stars aren't moving in conjunction with us. So, I mean, I'm not an astrophysicist at all. I don't know any of this stuff, but let's just say 5 miles an hour. Where do we get that number from? So how fast is the world moving? 460 meters per second. So what do they say?
Mile an hour.
5 miles an hour. No. That's already wrong. So I don't know why we're using bogus maths. Why don't we just use the real maths?
That the telescope was moving at 5 miles an hour and had to be tipped 5 degrees.
So these are arbitrary figures. I just want to make that clear before we move forward, which is fine.
This 5-degree tipping, however, could equally be caused by the ether moving at 5 miles an hour, carrying the stars around the Earth.
Okay, so... Okay, I need to think about this. So let's say, all right, we've got the planet, right? And then you've got your telescope, which looks like this. okay? And then you got your star here. I think that the distance that let's say our planet is moving in this direction. I'm pretty sure that this distance, and the speed that we're going is negligible for the distance that we're seeing these stars at. So, for example, if you imagine yourself on, let's have a look. Let's say you imagine yourself on a football field. Now, let's say you've got there's one person here and one person here. If this person is looking this way and they're moving, the distance that they're moving, the person is going to have to move their head in that angle at a certain rate to try and keep up with that person moving, okay? Now, let's say instead of, where's the brush? Paint's so good. Now, let's say instead of being that far away, you're this far away. Whoops, brush. You're this far away, looking up. Now, the difference in your angle of moving your head will actually appear to be much less. Well, actually, it will be much less. So, so when we do surveying, let me just clear that. So when we do surveying, we have these things called degrees, minutes, and seconds, right? So you got 360 degrees, then you have 360 degrees, then minutes, then seconds. It goes down further and further, right? And we have instruments like a digital level that measures to 1/10 of a millimeter, and that's measuring it with degrees, minutes, seconds of the theodolites that we use. So let's say we got let's say that we have a person here, right? This is a top-down view, and you have a theodolite with them, so they're standing on the point that they need to, like they're set up on their base station, the theodolite, and they're measuring to a what they call a backside here. The reason why we do this is because we want to measure our degrees and minutes and seconds. Excuse my handwriting. And then you want to measure the distance. So we'll just say D. Okay, so we want to measure the degrees, minutes, seconds, and the distance. Now, on 2D plans that we have these plans, and these plans will actually state the degrees, minutes, and seconds that this number needs to be. So then if we say, hey, we're standing here, we're shooting at this object should be, and we already have a predefined distance because of the plans, because of whatever surveyor set it out beforehand, and we have the angle. So then when we measure this, we're telling the instrument, hey, this is, it might be like 1642.01 or something, right? Some random number. And then because it knows that distance, it can then measure other distances. Okay, so then it can work out what other angles are based on that information. All right. And then we know, and then so, for example, if we're on a building site, what we'll do is we'll check this distance, and then we'll set up our theodolite, we'll point to a backstation, and then as a result, we'll then be able to set out points. So we'll be able to, where is my cursor? So we'll be able to set out like points. So like, let's say 4 bolt points for like a pillar that needs to go in or something, right? Or like, let's say a corner of a building, we'll set out corner points, we'll put a nail in, and then we'll draw some chevrons with some lines. The reason we can do that is because this long ass angle is a huge amount, like as far away as absolutely possible. And then we're setting out things that are much closer. And so a good surveyor will also do a check. So they'll connect to this long backside. Then they'll go, okay, so this is our line. And then they'll actually, what they do is they'll do a check shot, I haven't done it for a while, on another point, another known point. And they'll check it, and then they'll get these measurements, degrees, blah, 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 minutes, seconds, and distance, blah, blah, blah. And then they'll have a percentage of variation it can be, because maybe you didn't set the perfect instrument up perfectly. And it usually will be within like 1 or 2 or 3 or 4, maybe 5 seconds out, which is nothing. It's tiny, right? So if they're getting that amount of perfection over that, they know that where they're set up is actually pretty accurate, and they know that the measurements, that the angles that they're using will be pretty accurate. But you'll never really see someone now we get this. You never really see someone set up their base station here, shoot a backside here, check here, and then measure way out here. You'll never see a good surveyor do that, unless they're setting out something like a place where you got to dig a hole where it can be like meters, out or whatever. Because the reason you don't do that is because angles over long distances change dramatically. So back to our example with the world, right? So you got the world, you got it moving in this direction. And once again, I might be wrong about this, but this is where my thoughts are going. You've got the angle of your telescope pointing up to a star. This angle is of such a huge distance, right? So what's the closest star from us? The closest star is 5.265 light years away, okay? In kilometers, all right? So that is is that billion or trillion? I think that's 40 trillion kilometers away, okay? So it's a lot, whatever that number is, okay? So coming back to this, any movement in our little planet, even if we're moving 400 meters per second, is negligible in this situation. Negligible. It's not. It's. That's why we don't, I guess, see stars moving, because we're moving. We are moving at such a fast rate, but they're so far away that they appear not to move. Much like how when you see the moon, it doesn't look like it's moving necessarily. But if you're driving in a car and you see it against like the trees and stuff, you might think it's moving. Okay, jumping back into this video. So we'll go back a bit.
This 5-degree tipping, however, could equally be caused by the ether moving at 5 miles an hour, carrying the stars around the Earth, as we see here.
Okay, so what is the ether? Okay, ether also is okay. All right. So it's a classical element. Okay. Legacy, Ether and Lights. Okay, so I think this is proposing a different reason why they're seeing some differences in a telescope, right?
The light would be coming in at the same angle, and the telescope would still have to be tipped 5 degrees.
Okay, so I'm going to grant this, because I can't be bothered looking too much into the ether or whatever. I'm going to grant this at the moment. But the thing is, this isn't proof yet. This is just, hey, it could also be this. Now, for it to be more reliable than our current understanding of astrophysics and how light works, it would need to be able to make more novel, testable predictions. That is, predictions that we can make, if this theory works, then we should be able to see this really unlikely thing happen, and then it does happen, okay? So whichever has more novel, testable predictions is the one that's more accurate, is usually how science works, okay? So, and of course I'm butchering science, and I'm butchering a lot of words, and I'm talking in generalities, but I'm just giving you my take, okay?
So tipping the telescope does not tell us whether it is the starlight moving or the telescope moving.
Okay.
However, there is a simple experiment that can determine whether it was the Earth that was moving or the ether and starlight.
So this seems to be a rebuttal to an already made claim, not necessarily proof of a stationary Earth, but let's keep going.
All that you had to do was record the tipping required for any particular star, then fill the telescope with water, which greatly slows down the speed of light in the telescope.
No, not unless the telescope was like a light year long. Speed of light in water. Okay, so light travels at approximately 30,000 kilometers per second, approximately, right? In a vacuum, which has a refractive index of 1.8, blah, blah, blah. But it slows down to 225 kilometers per second in water. So we actually have to do this with our theodolites and our instruments. We actually have to measure the temperature, and we actually have to put in information about the atmosphere, because our lasers are going through the atmosphere, and it obviously changes the measurements. And obviously we're talking about we're talking about millimeters, right, over hundreds of meters. So this is accurate, but once again, the perceived difference between 300,000 kilometers per second and 225 kilometers per second unless you're using like extremely precise telescopes.
So here is the moving telescope filled with water, tipped at 5 degrees, and you can see that the starlight does not now reach the eyepiece at the bottom. This is because the starlight moves much more slowly when...
It doesn't move much more slowly. It moves like a percentage slower. Like it moves like, I'm bad at maths, like 20-something% slower.
Passing through water. However, if the telescope is tipped further, say 10 degrees, then the starlight will then be visible again in the eyepiece. It has to be tipped further because the light is now slower when in the telescope.
That could possibly work if you had some extremely precise instruments, but I don't think when measuring the ether, you'll be measuring with extremely precise instruments like that.
5 miles an hour. Then when it is filled with water, no further tipping is needed because the light is coming in at 5 degrees anyway. The starlight stays on the same path, but is only travelling slower in the water.
Wait, no. So is it saying that... This is amazing, because I think a lot of this comes from people's just inability to grasp how fast the speed of light is and how big the universe is. It makes them uncomfortable, they feel small, and then they latch onto theories like this. This is absolutely ridiculous.
The light is coming in at 5 degrees anyway.
To recap, if the telescope is moving, you would have to tip the telescope further when it is filled with water. No, not necessarily. That's what the person said, but we're talking like such minimal amounts over like of distance with such a incredibly fast medium, the fastest thing in the universe, light. Okay, so like this is not accurate at all. This is a horrible video. To recap, this is completely wrong. This is, what is this, the non sequitur hour? This doesn't work. And hang on, and also, if this did work, this wouldn't be proof of a stationary Earth. This would just be evidence of that one theory could also work to explain one part of another hypothesis. It wouldn't have anything to do with a stationary Earth. Maybe this is what it's addressing. If it is light from the star moving, the telescope had not to If it is the light from the star moving, the telescope had not to be tipped further when it is filled with water. If you have a grade 2 understanding, yes, but if you live in the real world where numbers matter and the speed of light is taken for granted for what the speed of light actually is, then it's not that at all. This is like when you get like little plastic dolls of dinosaurs, and like the Tyrannosaurus is with like all the other dinosaurs when they actually live like heaps long apart.
The result
this is so
of
stupid.
Airy's experiment.
Okay, so it's really good when you're talking about science to go back to the 1871.
Known as Airy's failure, was that the telescope does not have to be tipped further. This proved that it was the incoming light that was moving past a stationary telescope fixed.
What is this text? You can't read this. What are we just supposed to? It's three. What are we just supposed to say? Like, oh, okay, yeah. There's words there. It must be telling us something good.
To the stationary Earth.
I'm sorry, but flat earthers were so lazy.
This experiment is never taught to university science students.
Because it's stupid.
They might begin to question what they were being taught about the cosmos, the universe, the Big Bang, evolution, and much else.
Yes. Once again, like I predicted, I don't like the fact that evolution is an observable fact, so I'm gonna... I don't like that the universe is big. This is so stupid. Okay. Blah, blah, blah. More dramatic music. We're constantly being exposed to conflicting forces. Okay, so this is moving on to another argument that doesn't really have anything to do with the first argument. I'm not even going to even discuss it. But okay, so we're gonna look this up. Okay, so this is what flat earthers don't do. They don't look up the counters to their theories, right? So I've never looked this up in my life, and I'm going to show how quickly and easy I'm assuming it's going to be to just find the real answer to this stupid idea. Okay, so Airy's failure. All right, so let's press Control C if you're on a Windows. Okay, does Airy's failure prove the Earth is really flat? Let's see what other people are saying. Not at all. Airy was trying to repeat an observation made by a German astronomer a few years before. The failure is in 1871 experiment that George Airy undertook, which attempted to measure the drag on light that would change the stellar aberration of light from the suitable star that is almost overhead, hence almost zero refraction. But using a telescope filled with water rather than air, see the original paper, okay. The ether theory indicated that a different refractive medium should produce a different effect compared to the telescope filled with air. Okay, so that's the video that we just saw. The experiment was repeated a number of times on different nights, at times 6 months apart. The results of the experiment was that there was no evidence to support the existence of the ether. Interesting. The common name for this is Airy's failure. Concerns the failure of this experiment to demonstrate the existence of the ether. However, if you believe in the ether against all evidence, then you will conclude the Earth was stationary, even though the regular stellar aberrations observations indicate that it's not stationary. The notion that the stationary Earth is not proved or denied by the experiment. The notion of the stationary Earth is not proved or denied by the experiment, which is exactly what I said. It helped remove the luminiferous ether theory. Okay. So, like I said, it was a debunking of another theory, had nothing to do with the stationary Earth. Flat Earthers believe in the ether. I suspect many, mainly to annoy people as they don't understand it. My thoughts exactly, or people who don't or too lazy to actually look into it themselves. And when I say look into it, I mean reading sources that disagree with them, not everything that just disagrees with them in one big circle jerk. In part because if the ether did exist, then the classic experiment like Michael Morley and Airy would demonstrate a stationary Earth. Whoa. So it has nothing to do with the flat Earth model. It's all about trying to demonstrate a stationary Earth, and that's a load of cobblers. All right, so this is the text, and because you couldn't see it in the other video, you can see it in this video. Let's have a look at this. Okay, abstract. This paper contains the results of a series of magnetic observations taken in the east of France during the months of August and September 1869, when our instruments were oh so perfect. They've gone downhill since then. And it is a continuation of the paper on the survey of the west of France, published in the Philosophical Transactions for 1870, page 33. No change was made in the observers nor in the methods of observation during the two surveys, and the only alteration in the instruments was the substitution of 1869 of a Jones theodolite in lieu of the small altazimuth by Cook used in 1868. Observations were made at 21 stations in the following order. Okay. And from this, with observation of transit of a star, it was found that the measure of 25 intervals of wire ought to be 0.8693 inch, as measured with a pair of compasses. It was found sometimes 0.871, sometimes 0.875. This agreement is fully as close as it can be expected from the rudeness of this operation, and shows distinctly that there can be no error of principle in the method of evaluating the micrometer scale. Okay, you're talking about distances of trillions of kilometers with abbreviations in the measurements of 0.871 to 0.875. This does not show a stationary Earth at all. You could not even conclude that from this experiment at all. It would be impossible. And the reason I don't pull apart these videos is they're so poorly thought through. Like, if you're a flat earther and you believe in the flat earth model, I don't want to see another 2-hour video or another video on something. Give me a theory for the flat earth that can produce novel, testable predictions. If you don't know what that is, go to Google and type in scientific theory. And then you'll find the Wikipedia page. And then you can read up on what it means to be a scientific theory, like the germ theory of disease, like the theory of evolution, like the theory of gravity. These are the graduation points of ideas. They are the as confident as we can possibly get in science. A theory is a collection of facts that have come together to be able to make novel, testable predictions. Build me a theory of the flat Earth model that can make even one novel, testable prediction, and I'll be impressed. But if you want it to stand up against mainstream science, your theory needs to make more novel, testable predictions than the geocentric model of the Earth. Don't send me more garbage like this. Thanks for watching.